Hello students, welcome to this presentation on velocity analysis in mechanisms using the instantaneous center method. In our previous presentations we have seen the velocity and acceleration analysis of simple mechanisms by using the relative velocity method. In this presentation we will see the basic concepts of instantaneous center, the meaning of instantaneous center, the types of instantaneous centers, how many number of instantaneous centers will be there in a mechanism, how to determine them and how to locate them. All these things will be discussed in this presentation and the following presentations. Let us start. Now let us consider there is link AB and it has to move to the new position A1, B1. Now the way in which the link AB from its initial position will move to its final position A1, B1 may be thought of as follows. Firstly, the link will translate from its initial position to A1, B dash, translation motion, followed by that it will reach its final position A1, B1 by rotation about point A1. So firstly there is translation and followed by that there is rotation. That is how this link AB will reach its final position A1, B1. Now let us look at this figure. Again there is a rigid link AB and it has to reach the position A1, B1. Here slightly it follows another route. First there is a rotation about point A, occupies the position AB dash and then translates to reach the final position A1, B1. Now this is actually the combined motion wherein the rotation as well as translation motions are combined, and it is immaterial whether the translation takes place first or the rotation takes place first. Let us explore more about this. Again consider a rigid link AB. So it has to reach its final position A1, B1. First there is translation to position A1, B dash and then there is rotation about A1 to reach the final position A1, B1. On the other hand, the same rigid link AB can reach its final position A1, B1 first by rotating about point A and reaching the position intermediate position A, B dash and then by translation it will reach the final position A1, B1. So here the translation occurs first and then rotation, and in this case rotation occurs first and then translation. So whatever the type of motion is, but it is the combination of two types of motions, the translation and rotation or rotation and translation. Now what is the implication of this? Now in actual practice the motion of any link is so gradual that it is difficult for us to see the two separate motions vividly, clearly. But we see the two separate motions though the point B moves faster than point A. Point B moves relatively faster compared to point A. Thus this combined motion of rotation and translation of the link AB may be assumed to be motion of pure rotation. That is very, very important. So here the combined motion of rotation and translation of any rigid link may be assumed to be as the motion of pure rotation about some center denoted by letter I, which is called as the instantaneous center of rotation. Also it is called as centro or virtual center, and many times it is abbreviated as IC. instantaneous center. Now in this figure, this link AB, which is having both the translation and rotational motion here, it offers about this point I, the instantaneous center of rotation. Now since the points A and B of the link has moved to A1, B1 respectively under the motion of rotation as assumed above, therefore the position of the center of rotation must lie on the intersection of the right bisectors of the chords A1 and B1. So these are the chords A1 and B1. This and this, these two are the right bisectors of A1 and B1, and if they are drawn, they will intersect at point I, the instantaneous center of rotation. Now these bisectors intersect at I, which is the instantaneous center of rotation or the virtual center of the link AB about which it rotates. So this is link AB. So it is a more elaborate explanation of the previous slide. Moving to the final position A1, B1. So A1 and B1 are the chords, and drawing the bisectors of A1 and B1, they will intersect at the point I, the instantaneous center of rotation. Instant means at this moment. Next moment this center position may change. It is different. But for this moment, for this instant, this is the instantaneous center. For some other position of the link, the I position may be somewhere here. That is why it is called as instantaneous center of rotation of the link. Now let us have some more discussion on this. So from the previous discussion, we see that the position of the link AB goes on changing. Here it is, it has reached here, after this it may reach somewhere or go somewhere. Therefore, the center about which the motion is assumed to take place, that is this instantaneous center, this also goes on changing. So for this particular motion of the link, this is the instantaneous center. If it moves from A1, B1 to some other position A2, B2, this may have another instantaneous center here. So as the link moves from its position, current position to some other position, next position, the instantaneous center also change. Now under this situation, the locus of all such instantaneous centers is known as centroid. If these all instantaneous centers are joined, you will get a locus of that, a curve of that, and that is called as centroid. Centroid is nothing but the locus of all the instantaneous centers. A line drawn through an instantaneous center and perpendicular to the plane of the motion. This is the plane of the motion, plane of the screen you say, plane of the paper you say. In this particular plane the link is moving, and a line drawn through instantaneous center and perpendicular to this screen is called as the instantaneous axis. This is the instantaneous axis, and the axis passes through I and perpendicular to screen or paper, and the locus of this axis is known as axode. Now let us understand about two more terms called as space centroid and the body centroid. In this figure there is a link A1, B1 having the relative motion with respect to a second rigid body supposed to be fixed in space. Assume some link is there in space and assume that it is fixed, and this link A1, B1 is having plane motion with respect to that fixed link which is there in the space. In other words, the instantaneous center is a point in the body which may be considered fixed at any particular moment. Now coming to the meaning of the space centroid, the space centroid is nothing but locus of the instantaneous center in space during a definite motion of the body. So here, for this particular position of the link A1, B1, this is the instantaneous center. Now for this position of the link, for the position A2, B2, this is the second instantaneous center. Maybe here another position of the link A3, B3, we may have one more instantaneous center here. Now if we join all these instantaneous center, that curve is nothing but, or that locus is nothing but the space centroid. Now on the other hand, body centroid is nothing but the locus of the instantaneous center relative to the body itself. Relative to the body itself. Body itself means, here you have said that there is a rigid body which is supposed to be fixed in space, and with respect to that this link is moving, and assume that this link is fixed and the fixed link moves. The fixed link which is there in the space about which this link is moving. Now assume that this link is fixed and that rigid link is moving. So when the body which was earlier fixed made to move with respect to this link, it will have the centers like C1, C2, C3, etc. Now if you join all those centers together, and the locus is known as the body centroid. And one more important conclusion that we draw from the body centroid and the space centroid is that these two centroids have the instantaneous center as a common point at any instant. For example here, and during the motion of the body centroid rolls without slipping over the space centroid. Now let us try to understand in a better way the concept of space and body centroids in the next slide. Suppose there is a 4-bar mechanism ABCD having 4 links 1, 2, 3, 4. Out of these 4, link 1 is fixed. For this instant, for this particular inclination of link 2, we have the instantaneous center here I13. Now let us assume that the mechanism moves to the new position, this position, and for this position the instantaneous center is this one. Again assume that the mechanism occupies one more position, and for that the instantaneous center is this. So I13 is nothing but the instantaneous center of rotation of link 3 with respect to fixed link 1. Here also, for this particular position of the mechanism, I13 is nothing but the instantaneous center of rotation of link 3 with respect to link 1. Similarly here, for this position, this is nothing but the instantaneous center of rotation of link 3 with respect to fixed link 1. So if you join all these instantaneous centers, and this curve or the locus is called as the space for the fixed centroid. Okay. So that means with respect to this fixed link is there, and any number of positions you take here, so it will have this same curve, that is what is called as fixed centroid. Now on the other hand, let us assume that instead of link 1 being fixed, let us fix link 3. So here link 3 was body under motion with respect to this another body, rigid body, which is supposed to be fixed. Now the body itself, the rotation of the body itself, okay, the fixed with respect to earlier fixed one, but now it is fixed and moving with respect to earlier fixed link. Earlier one was fixed. Now let us assume that the link 1 moves with respect to link 3. For this particular configuration, this is the instantaneous center I13. Instantaneous center of rotation of link 1 with respect to 3 for this position. So again, say link 1 moves to this position, and this is the new instantaneous center of rotation of link 1 with respect to link 3. And similarly, for this position of link 1, this is the instantaneous center of rotation of link 1 with respect to link 3. Now if you join all these centers, what you get is called as the body or the moving central. Okay? It is the locus of the instantaneous center with respect to the body itself. Now this is the space centroid or the fixed centroid. As I have discussed already, this body centroid rolls without slipping on the body or the moving centroid. This body or the moving centroid rolls without slipping on this space or the fixed centroid. This is fixed and this is moving. This moves. Okay, this is not fixed, it moves. Okay. Now let us try to understand the different properties of the instantaneous centers. The first property of the instantaneous center is that a rigid link rotates instantaneously relative to another link at the instantaneous center for the configuration of the mechanism considered. A rigid link rotates instantaneously at that instant with respect to another link at the instantaneous center for the configuration of the mechanism under consideration. Second important property of instantaneous center is the two rigid links have no linear velocity. The two rigid links have no linear velocity relative to each other at the instantaneous center. Means at the instantaneous center, the two rigid links have the same linear velocity relative to the third rigid link. In other words, the velocity of the instantaneous center relative to any third rigid link will be same whether the instantaneous center is regarded as a point on the first rigid link or on the second rigid link. We will see in the second part of this presentation more about this. Now, coming to how many number of instantaneous centers that a mechanism will have. This is a very simple formula which gives the relation between the number of instantaneous centers capital N and the number of links that are there in a given mechanism. So it is capital N, nothing but number of instantaneous centers equal to N into bracket N minus 1 divided by 2, where small n is the total number of links in a mechanism. By using this relation, we can determine the total number of instantaneous centers or instant centers that are there in a given mechanism. That is the end of the part 1, students. In part 2, we will see more about the concepts of the instantaneous center. Thank you.